Hi, and welcome to HTML5 and What's Next. My name is Alex Komorowski. I'm a product manager on Chrome, focusing on the open web platform. And I'm also a web developer myself. Spent many years working on the web platform, and that's why I'm so excited about making it even better.
Hi, everyone. My name's Fette. I'm a product manager on Google Chrome. I joined the team about 4 years ago, working on security and infrastructure like networking stack and disk cache. And for the past few years, I've been focused on HTML5.
Hi, I'm Alex Russell. I'm a software engineer on the Chrome project, working on Chrome Frame and the Chrome web platform more generally.
Cool. So before we get started, here's the speaker meter link for this talk, as well as the hashtag if you feel need to tweet. Today, if you came to any of the earlier talks, you saw a lot of really cool demos about what you can do with HTML5 today. Today, we're going to also continue that by telling you about capabilities that are being built into the platform today, including Filesystem, WebSockets, and 3D. But we're also going to spend a lot of time talking about the future of the web platform. Really how you can unlock the potential, what we think is important for unlocking the potential of the web platform going forward. Some of the things we'll talk about are so new. They're still under discussion. There's no spec for them necessarily yet. And they definitely aren't implemented. But we think it's important that these kinds of things are going to be important for making the web platform even better going forward. We'll talk about things, some proposals for CSS, for JavaScript, and also something we call model-driven views. But first, let's very quickly just review kind of how we got here on the web platform. Now, the web platform started out, obviously, a long time ago, as a way to share very simple documents written in HTML. But of course, that wasn't enough. People wanted to be able to style their stuff, so now you have CSS. And of course, people wanted to be able to add simple behaviors, and so you have JavaScript. And people pushed that basic capability so far, they built things like Google Maps and Gmail and Google Docs. You have apps, real apps being built on a platform that originally was designed for documents. Now, of course, the web platform hasn't stayed still. It's been adding tons of capabilities. You can do some really amazing stuff with it now with complex graphical effects, video, even 3D. And we're adding more and more capabilities to the platform all the time, really expanding the vocabulary of what you can say on this platform. But remember that this platform did originally begin with static documents. And although it's a very full-fledged, full-featured platform, some of these features were sort of ad hoc. And it takes a lot to wield the power inherent in the platform today. So although today you can build incredibly, amazingly beautiful, powerful apps, it requires a lot of JavaScript. And it requires you to basically be what I would describe as kind of a web development ninja. And not everyone has the patience to become a web development ninja. And that's why we think it's important not just to expand the vocabulary of the platform, but also to focus on making it so that you don't have to be a ninja to write delightful apps. We think that by doing that, it will really unlock the potential of the platform. And we think the way to do that is to allow developers to say what they mean. But before we get to what I mean by say what you mean, let's go to Ian to hear more about the capabilities in the platform today.
Thanks, Alex. So quick question. How many of you were here for Google I/O 2010? Awesome. I see a lot of hands. And it's really cool to see so many people here, because last year, when Chrome was giving some talks, we were in what was then the largest room that held about 500 people. This room here holds about 750 people, and it looks quite full. So I'm very excited to see all these people sort of interested in knowing what's going on. So, Alex sort of gave a great lead in. We do think it's important to let you do more on the web, to expand your vocabulary, to let you be more expressive in the types of applications that you want to develop. We talked a little bit last year about what we're doing, and I want to give an update of what's going on in terms of new capabilities that we're adding to the web platform through Chrome. So if you were at Eric and Arne's talk this morning, you actually saw Filesystem being demoed. Filesystem is something that we first talked about it at Google I/O 2010, so almost a year ago. There have been a lot of changes since then, since Chrome 8 when we introduced this. For those who aren't familiar with Filesystem, I've got a snippet of code that sort of shows what you can do with a file system. Here I'm requesting a file system that's temporary, and I'll talk a little bit more about that later. I'm creating a file, just a simple log file. I'm going to move to the end of the file. I'm going to get a writer for the file so I can write to it. I'm going to seek that to the end. I'm going to write some data to it. So Filesystem is an API that lets you store data on the user's computer. Relatively straightforward. I want to talk a little bit about some of the changes that have happened since Chrome 8 to actually let you use Filesystem and let you use it in a more useful way. So perhaps the most boring change since Chrome 8 is we used to have a lot of references in the spec to URIs. These are now URLs. It's sort of very simple and straightforward and boring, but I wanted to get out of the way so we could talk about more interesting changes. So what's actually interesting in file system land? Well, when we first introduced this API about a year ago, it was only usable within the context of Chrome apps and Chrome extensions. And if you're developing a Chrome app or Chrome extension, you can use this now. You can request unlimited storage quota, and you can save things on the user's hard drive in a structured way in a file system. And that's great. But we've gotten feedback that there's a lot of people that don't necessarily want to have to get users to install a Chrome application or a Chrome extension just so that they can use this API. So we're working to make this available outside of apps and extensions. And we're hoping to have this working on Dev Channel by the end of the month. So in Chrome 13, we are going to enable this API outside of apps and extensions. So that's one big change. But the second big change, for those of you who have tried to use a lot of the storage APIs, be it file system, web SQL database, index database API, app cache, you often hit this 5 megabyte limit. And you're like, wow, what can I actually do with 5 megabytes? Like if you're trying to store a user's email, my inbox is somewhere around 30 gigabytes. You're going to hit that 5 meg limit pretty quick. If you're trying to let users edit photos and then upload those, again, 5 megabytes, it's like, poof, gone. So it's like, well, can you just get rid of that 5 megabytes? Well, no, we can't, because if we just get rid of it entirely and say, sure, we'll store data on the user's computer and we'll never delete it, it'll be there for you, then anyone can sort of just fill up the hard drive. So this isn't a good solution. So what we're trying to do is we're trying to introduce a notion of quota. And the way that we're doing this, there's two things happening. One is that we now have a notion of two types of quota. One is temporary, one is persistent. And the way that you interact with this quota is through an interface called storage info. So before I get into storage info, let me explain what temporary and persistent quota are. First of all, a lot of APIs nowadays are requesting, they're requesting some capability, and then the browser puts up this modal dialog or this info bar and says, hey, user, can I do X, Y, Z? And we really want to avoid this as much as possible. So what we're doing by creating temporary quota is we are saying, you, the developer, can store things on the user's computer. You can already store things like cookies, so the actual impact of storing something on the computer is not that great. And we won't ask the user, we won't put up any annoying dialogues. We'll just let you have some storage. So you can say, hey, I want to make the user's email available for offline browsing. Give me 5 gigabytes of temporary quota. And we'll say, sure. There's like 500 gigabytes free on the hard drive. Here's your 5 gigs. Have fun with it. And you can keep doing this and getting more quota. But eventually, we're going to run out of space. And the key thing about temporary quota is that it's managed by the browser. So if another site requests quota and there's none available, we have to figure out as a browser, how do we make this available? So we, the browser, will feel free to delete things in temporary storage to make room for applications that users use most frequently. This lets all the management happen outside the user's view. There's no annoying dialogues or prompts, and it just works. But that doesn't work for everything. What if you're an offline email program and the user is typing up an email? You don't really want that email they've composed to get deleted by something else. So temporary storage doesn't work for everything. For this, we have the notion of persistent storage. So if you request persistent storage, we guarantee you that we won't just evict it. We won't delete it. Because of this, we will ask the user for permission. So we're hoping that together, this will enable offline apps to actually make use of the storage APIs. The interface for this is quite simple. You can query how much quota you're using, and should you need to request quota, there's a simple API to request quota. So this is what's going on in the land of storage. What else is going on? Well, last year we talked a little bit about WebSockets. WebSockets, as you can see on the screen, is an API for bidirectional communication. So a lot of applications do this today, things like chat. You're sending chat messages, updates back and forth to a server. If it's email, you might be polling for email. And although it's possible to do this, it's very inefficient right now. You often have to open 2 connections. You're sending a full HTTP request with headers, cookies each time. And even if you're sending just one word, 5 bytes, that might get blown up to hundreds of kilobytes. potentially, depending on all the headers and cookies and who knows what else. So WebSockets is meant to be a very simple API that lets you send and receive messages over a persistent connection. The spec is now in last call as of April, so this is really getting finalized. We've got a lot of browser interest. All the browsers are looking at this. Microsoft has an experimental implementation out that you can download. Firefox and Opera are both also working on it. So a lot of momentum around WebSockets, and now we're sort of changing our focus to multiplexing to let you have even more connections open at one time and still be efficient. And last but not least, 3D. Those of you who were at the keynote this morning, you got to see Angry Birds in 3D. This is my absolute favorite. I'm sort of addicted to it. There's been a lot of progress in 3D. So as of Chrome 9 back in February, we now have WebGL enabled by default, not just on the latest, greatest Windows 7 computers, but also for people who are running Vista and XP as well. So WebGL broadly enabled. That's really cool if you're building games or things with immersive 3D environments. But what if you want to just sort of add some 3D flair? You've got, like, if you look at the new tab page in Safari, it's got these cool 3D perspectives. A lot of things make great use of 3D, not for like a fully immersive gaming environment, but just to add some nice flair, some nice perspective. 3D CSS transforms are a very easy way to add this into your application. I'm very excited to say that as of Chrome 12, we now have initial support for a lot of the 3D CSS transforms. And as Sundar said this morning, Chrome 12 is now going out to the beta channel. So this is something that you can already use and will be out to all users very shortly. So we're doing a lot to sort of expand your vocabulary, let you say more things, as you will. But sometimes this can be a bit overwhelming. And so to talk about what we're doing in that aspect, I'd like to welcome Alex Komorowski back.
Thanks, Ian. So that was an overview of some of the stuff that you can do today in the web platform. But now let's take it and look towards the future. So once we've gotten to everyone having all of the pieces of HTML5, what's next, right? The problem right now is that you have this huge vocabulary, but it isn't necessarily easy or short or succinct to say the things that you want to get across. This isn't just a theoretical problem. This is a problem you're running into every single day. Even for simple sites, popular sites, well-implemented sites, you're doing a lot of things. You're saying a lot of stuff just to get some basics across. The way I think of it is that the web platform of today is kind of like a savant. He's amazingly smart, and he's amazingly effective at doing precisely what you tell him to do, but he doesn't understand that much about the real world. You have to spend a whole lot of time explaining to him precisely how the world works, and you do all this via JavaScript before you can tell him to do anything that's particularly useful. And you can do this. It's possible to have these conversations, but why should you have to? Why can't you just have a normal conversation? And we think that's the future. That should be the future of the web platform. Moving from this idea of saying what you must, this very comprehensive encyclopedia of information, and moving just to saying what you mean. Why should you have to write an entire encyclopedia and ship it down the wire when all you really want to say is a short story? This is something that we think is really important, and that will unlock a lot of the potential of the web platform. And we think there's lots of benefits from this, or good reasons to do this. The first is reducing maintenance burden. The more code you have to write, the more surface area you have for bugs and typos. But there's something else, too. If you codify in your encyclopedia of knowledge about the world that a car is something with an internal combustion engine and that uses fossil fuels, well, it's going to continue being that way, even as electric cars become the norm. Whereas if you can rely on the platform more to understand these things natively, these common patterns, then as electric cars become normal, you sort of get that for free. You just say, hey, give me a car, not give me something with an internal combustion engine. Another way to think about it is that you reduce time down the wire. So one of the great things about the web platform is you have this enormous reach. Anyone with an internet connection on any number of devices can get your app. But they also have to be shipped down the wire. So if you're shipping down an entire encyclopedia, that's going to take time. But if you can be succinct, if you can just ship down your short story, you can get to your users much faster. Another way, of course, is execution time. If you've got this whole encyclopedia that the browser has to read and understand, that's going to take some time, even with really fast JavaScript engines like V8 and on other browsers. This is something that will always take time. It will never be quite as fast as native code. There are two ways to fix this particular problem. One of them is by increasing the reading speed, increasing how quickly these engines can process this stuff. That's incredibly important, and of course, everyone's working on it. But there's a second strategy, a supplemental strategy. And that's reducing the amount of stuff you have to say that the browser has to understand. You're raising up the common patterns and allowing you to express that natively so that more logic can run natively and it can run fast. That means that you don't have to process this entire encyclopedia before you can get to the juicy stuff, the good stuff, the stuff that you actually care about. But the final way, and I think the most important way, is reducing cognitive overhead and complexity. You as a developer only have a certain amount of patience and time. And right now you're spending a lot of that building up this encyclopedia when really all you want to say is this short story. Even if you're building on top of existing encyclopedias and existing frameworks, there's still some overhead there. Each of these frameworks has to build up their own version of the world and explain it to the browser in an incompatible way. So, if you're driving a BMW, parts from the Toyota probably aren't going to fit. You can't pick and choose pieces from across these frameworks. So again, we think that the web platform of today is amazingly powerful. It's getting more and more powerful every day. But now we think it's important to really focus on allowing people to say what they mean, to really usher in a new era of amazing web apps. And so that's sort of the high level, but now let's turn to Alex Russell for some specifics. And again, just to set the context here, these are ideas that are so new, they're so cutting edge, that they aren't in specs yet, let alone being implemented.
Thanks, Alex. So as Alex laid out the cogent case for why we need improvement in not just the vocabulary, but sort of the slang, the common use case of the languages that we use every day, it's important to ask the question, what is it exactly that we need to change? So if we go and we sort of ask anybody and say, what is it that you would like to be different about the web platform, we'd get a lot of different answers, and in fact we have. And so what we've done instead is go and look at the largest applications that we're building, because they sort of have aspirational levels of complexity. When you throw hundreds of engineers at a problem, you can expect them to build something that a couple of guys in a garage won't be able to do over a weekend. And so what we'd like to do is make it possible for you to build richer, more complicated, more sophisticated applications without having to work as hard. And so if we look at the biggest applications that we've got today, we started to ask ourselves, what are the areas where we could get the biggest bang for the buck if we take the common things that everyone's trying to do and just put them directly in the platform? So one of the big things that has been clamored for by developers since the early days of CSS has been the ability to refactor your CSS in a lot of different ways. The first of them is variables, where variable names in programming languages are actually descriptive. They're not just chaff. They're not just sort of like a stand-in for your own understanding. They wind up being the language that you use to communicate to yourself later and another programmer about what it is that this value does. And so what we've looked at is how we're using CSS in the real world. CSS style sheets have gotten very large, and factoring your CSS has turned into an incredibly important task for many large websites. And so CSS variables unlock a lot of the potential to do exactly that. And so we're working on a syntax that's been proposed on the CSS working group mailing list to help us do exactly that. We're using a new @ rule. As you can see in this case, we're going to create a base version of this value, which otherwise has to be repeated over and over again in the example at the top. Instead of repeating the values, we can start to repeat what it is we're trying to say inside of our CSS. CSS variables help us factor stuff out. And this is going to be great for themes. This is going to be great for building stylable websites in which you can put the burden of maintenance not just on one person who has to know the entire system all at once, but you can hand over your variables sort of as the contract for how you want to theme and style your CSS rules. So this is really good. CSS variables give us the ability not just to do this statically, but we also want these to be dynamic so that you can come back later with JavaScript and change the value and have them change live in a document. CSS variables can be an incredibly powerful way to add dynamic behavior, not just sort of macro style one-time fire and forget behavior. So the next thing that we looked at when we were looking at very large style sheets, the sorts of things that get generated from large teams or from the preprocessors that are so popular now inside of client and server-side toolkits, is the idea of factoring out common sub-expressions inside your CSS rules. So if you look at CSS rules today, we've got media queries, which give us the ability to say, please turn on or turn off this set of CSS rules for some environment. But after that, there's no sort of layer that allows you to target some chunk of CSS to some portion of your document. Because what happens in small documents is that you write very terse, very expressive selectors and rule bodies, which only have to operate on a small chunk of DOM. But when we build really big applications, we build those big applications out of similarly small chunks of DOM. But if I write a very small rule that has a descendant selector or is relatively naive about what it's going to target, I wind up in a place where I have to defensively prefix all of my CSS rules with some ID or some class name so that I'm not over broadly applying my CSS rules to some portion of DOM that I didn't mean to. We're trying to get to a place where we can think about CSS and HTML having this component. So today we wind up with these shrink-wrapped rules with a lot of prefixes to get there. And so one of the things that we think is going to be helpful in this case is the ability to factor out common subexpressions so that you can mix things in like a function would. You can say, I don't want to have to write out the code that does this thing every time. I just want to import it into my CSS rules. And CSS Mixins give us a way that's analogous to using variables, but instead not importing the value of something, but importing a bunch of different rules into a particular CSS rule body. So in this case, we've got a themed button, and the themed button doesn't want to have to care about which style of linear gradient syntax is supported in which browsers. Instead, it wants to use whichever one is going to be available. CSS has been evolving in a very compatible way thanks to this vendor prefixing, but it leads to kind of a diarrhea of vendor prefix names when you mostly have the same thing supported everywhere, but nobody wants to implement the exact same unprefixed thing, lest the spec change out from underneath them. And there's some transition period after browsers support the new thing, because not all browsers update automatically. So we need a way to stop saying the same thing over and over and over again when we just want to say it once. And Mixins, defined with this new @trait rule, give us the ability to do exactly that. We can pass in variables to Mixins so that they can be parameterized, and then the local name for that can be populated into the rule. You can think of this as sort of simply expanding in line inside of our themed button class, exactly what we were going to say longhand, but we can reuse that over and over and over again in different CSS rules. It's sort of like a macro. So that's pretty good. It's a macro that we can configure in a bunch of different places to refactor and factor out common subexpressions and common behavior. So I mentioned earlier that we wind up doing this shrink wrapping thing, where I have a little chunk of DOM, and I want to factor out some common rules that apply only to that thing. Mixins give us the power of saying, aha, when I want to reuse some set of rules that apply in a bunch of different rules, I can just turn them into a function or a mixin that I can use in different places. But at the same time, we want to make that stuff appropriate only for the DOM that we care about. So this is an example of some CSS from an earlier version of this slide deck. So this CSS, as you can see, has .slide.image as this prefix that gets used for a whole bunch of rules that come after the initial formatting for this chunk of HTML. And these rules roughly correspond to the structure of the HTML that these rules should apply to. So in this case, any element underneath this slide image that's got a credit should have this behavior, whereas any counter element should have a separate set of styling applied to it. And so in this way, we wind up using descendant selectors with a prefix to sort of replicate the structure of our document in our CSS so that we don't over-apply rules and that we don't under-apply rules, so that we wind up with exactly what we meant to say in our document without creating a problem for somebody else. Specificity helps us here. But it's very verbose. So what we're proposing is the idea of CSS nesting and hierarchy, where you can write rules in a hierarchical way. Using the new ampersand character, we are effectively doing exactly the same thing, shortening up the subrules by saying, when I want to target an element underneath the slide image with the credit class applied to it, simply repeat the selector that was written out at the beginning in front of this rule here. It's sort of like you're not doing the loop unrolling for the system anymore. Dave Herman at JSConf last week said that he doesn't think that humans are very good compilers and that nobody should be a compiler. Compilers are compilers, and I agree with that statement. We want you to be able to write only the stuff that you need to say in order to get your job done. And so being able to nest your rules makes it read like you would actually see the HTML that you're trying to target here. And using the ampersand to stop repeating yourself so much makes it possible to read the CSS rules without quite so much visual cruft and without sending so much down the wire in order to say exactly what it is you were trying to get to. That's pretty cool. It's worth noting that all these things compose together, too. CSS nesting and hierarchy works inside of mixins. So I can have a mixin that has hierarchy inside of it. Variables work with all of these things. So we're starting to get to a place where CSS is a really expressive language that helps us map behavior and visual formatting back onto HTML in the way that we want to write our HTML in the first place, structurally, semantically, and in a way that is very clear to read. So that's great. That gives us some really powerful tools for maintaining our CSS, structuring it in ways that are reusable and maintainable and that don't have high complexity, reducing the size of our CSS down the wire so that we don't have to fight so much for performance. But we have a couple of other parts of the platform that could use some love here too. We've gotten out of the world of JavaScript animations recently, especially in mobile platforms, by using CSS animations and transforms. And CSS animations and transforms are a great way for us to put the job of making things fly around the screen onto the browser. We don't have to do it in JavaScript. We don't have to ship down a library in JavaScript that's going to do the work for us. We don't have to come up with a whole set of pre-built easing functions. That can all be put into the browser. It's really powerful stuff. And it's sort of de rigueur on mobile platforms today. But we wind up with a couple of problems as we start to exercise the edge of this syntax. It's great stuff, and we really want it to be as easy to use as possible. But today, it's a little bit unclear when I look at an animation or a transition what it is it's supposed to do. I think the easiest way to sort of communicate what it is animations and transitions do is to think of transitions as being edge-triggered. When I want to migrate from state A to state B, the transition helps me communicate visually about that transition, that change in state from point A to point B. Whereas animations are things that happen at the level in my step function. They happen when I reach that state. When I get to that state, then kick off the animation. And so transitions are designed to help you interpolate from point A to point B, whereas animations aren't designed to help you interpolate. They're designed to help you express some visual behavior in a way that's very compact in terms of expression for a fixed set of things, but it doesn't give you a way to reach in and say, where did I start from and where did I go to? So it's not clear which one you should use for each task. If I'm communicating visually about what just happened in my application, I might want to use a transition, but there's some missing expressive power. If I use an animation, I have complete control. I can declare an entire set of joined behaviors and visual artifacts that I'd like to have spring from me arriving in a place, but I can't tie that to the beginning and end states of my application's behavior. And most of all, when I write my CSS, I sort of think of writing my CSS as a series of states. My CSS rules, in this case, the hover class, are a great example of wanting my CSS rules to express positions that my elements might be in, roles or states that they might take on. And so if we want to reuse that language on the selector side of my CSS, we need a way to tie our transitions and our animations more tightly to that graph of potential states. So we're proposing a new set of syntax to help you do exactly that. In this case, we're going to reuse the CSS for the button and the active class as a way of tying this state-interaction role to it, which is a way of saying my button is going to participate in sort of a new set of classes. And in this case, that's going to be the interaction. And whenever I am in the active state, that interaction is going to go from normal to pressed. So when that happens, now we want a way of targeting that with some new expressive behavior for visual formatting. We don't want to have to put that in our JavaScript. We don't have to have that happen from events that happen in programmatic code. Instead, we just want this to happen because the CSS transitioned us from one place to another. So what we've got here is a new @transition rule. And the new @transition rule says, when I target the button class and I move from normal to pressed over the interaction state, then run this animation over this frequency. And if I wind up interrupting this, if I wind up coming back and not applying the active class for a tenth of a second, reverse the animation, automatically reverse it. Today, this is a lot of code to go do. And this is really powerful stuff because it means that we can write our CSS as though it is a series of states that we transition to and through. And then we can tie our behavior, our visual behavior, directly to those transitions. So this is a little bit of code. This is the smallest code I could write to go and figure out a way to take the start and the end of CSS animation and configure them for something. I don't expect you to read this or understand it, but basically, I pull in a library, I write a function which is going to go substitute some values in and out, because today CSS animations can't be subject to some relative start and end state. So what we need to do is go calculate that start and end state, add it to the keyframes, add it to a new rule, apply that rule and those keyframes to the document, and then trigger them. Well, that's a lot of work to do in JavaScript. It means that you now have to go write all of this out and trigger your animations through JavaScript. It's kind of a pain. We don't really want to end up doing this. Instead, it would be better if CSS gave us a way in our keyframes to say, wherever I started from and wherever I'm going to, calculated by the engine, please go run this animation in a relative way to those start and end states. And so we can combine that with calculation. And in this case, we're going to fly from some position on the left, wherever we started, to some position on the right, but we're going to bounce. So we can use the keyframe system that's available for CSS animations today, but parameterize it with where we start and where we end to tie the animation syntax back into the transitions so that we can visually communicate about the sorts of things that our application is trying to do and configure it with this rich visual language that we have in keyframe-based animations. Again, we're going to tie that back through a transition so that when we move over any class that has the state dash left interaction state associated with it, we can then apply this animation. So it's a really great way of starting to think about writing your CSS as a series of nodes in a state graph. And when we have a transition from one node to the other, you can start to address the edge of the state graph, as opposed to trying to back this stuff into your selectors, where you might otherwise have to try to target something with a bunch of additional ID or class rules in order to kick off some particular transition or some particular animation. We think this is really powerful stuff, and it's going to open up a whole bunch of new complex behavior in animations and transitions. But we're working in a bunch of other areas, too. At the last hour, I gave a talk on JavaScript, and at JSConf and NodeConf last week, we unveiled a JavaScript to JavaScript compiler called Tresor. And Tresor's role is to help us innovate in exactly the same way, but for the JavaScript language, so that we can start to prototype ideas out quickly, work with the standards committees, work with the broader community to help understand whether or not these ideas are good ideas or bad ideas. As Alex said, a lot of this stuff is pre-standards. We're working hard to make sure that these are the best designs we could come up with, but we need your help to do it. And so we're working in CSS to go add a whole slew of other stuff too, because CSS is one of the weaker parts of the web platform today. CSS rule values, CSS layouts, better performance, a layout model that's easier to use and easier to understand when you're positioning things relative to each other, and a real object model for scripting all of this. These are the sorts of things that we're focused on, and we don't have time to go through all of them today, but I hope that you'll engage with us through the XS project, which is on Google Code today, which gives us the ability to prototype this in a preprocessor style, the same way that Tresor does for JavaScript, less Sass, the sorts of preprocessors that you might have come to use, but it operates on the client side. And so it's a really powerful facility for helping to prototype these features, use them early, and get started with a bunch of the new capabilities that we hope that you're excited about for the web platform too. So as I mentioned, we're working in Tresor to help improve JavaScript, and improving JavaScript happens at a lot of levels. JavaScript as a language doesn't necessarily just have its own library. The DOM is an important part of the JavaScript ecosystem, and so we're working with not just the ECMAScript standards body, but also the WebIDL standards body to help make a lot of the things that you do in JavaScript more natural, working on a CSS object model to help make interacting between JavaScript and CSS much more natural and more fluid, so that as a JavaScript programmer, you don't have to think of these things as being alien to your environment. They act the way that everything else in JavaScript should. And hopefully, through the Tresor project, you can help inform us about whether or not we're scratching your itches too. So the last piece I want to sort of go through today, one of the big pieces of infrastructure that we've identified as a common thing for web developers to do that doesn't have a lot of platform support today is the idea of templating or data binding. Those are both scary words, I understand. There's a bazillion templating languages in the world, and data binding is something that isn't the sort of idea that you really want to foist on the newbies. HTML is a great language because it allows you to go from 0 to amazing applications on a relatively linear path. And so we don't want to put a lot of code in the way between how you start writing your application and where it eventually ends up at. We want a smooth glide path, and HTML and the web platform have done a very good job at providing exactly that. If you can't get it through HTML, maybe try it in CSS. If CSS doesn't do it, maybe you go to JavaScript. So these things have sort of fit together or composed together in a way that's allowed us to evolve from just a document rendering system to a place where we're building real applications. And that's a property that we want to preserve. So we asked ourselves, when we generate all this stuff on the client side, what is it that we're trying to do? And the key insight that Raphael Weinstein and Eric Arvidsson and some other folks have come up with is that data binding and templating are exactly the same problem. They're two sides of the same coin. On the server side, you wind up writing a templating engine that takes some data, mixes it together with some templates, and then spits out a string. Well, why does it spit out a string? Well, because it's on the server side, and you have to serialize it to send it to the client. On the client side, you wind up taking that generated thing, because it's pretty fast, and you wind up trying to attach some out-of-band model or view to it so that when something changes through JavaScript events, you can go be informed of it and then tell the server and reserialize the changes that you'd like to notify the server of. What if instead, on the client side, we were able to take a lot of the templating and do it right there? And so this is some sample syntax that we're working with now, where we're introducing a new template element into HTML. And that template element is creating an inert chunk of DOM, which in this case we're going to use directly because we're going to iterate over some property. But in that inert chunk of DOM iterates over some items. It has an ID. It is actually an element. And then it's going to go grab some properties out of the current item that it's iterating over. In this case, we've got another template that we're going to use, which is going to iterate over the children property of the current item. But it's going to not define its own template. It's going to refer to another one. In this case, we actually have recursive templates here in very little code. This would have been a lot of JavaScript to write. It would have been a lot of code to send down the wire just to do the string replacement. But later in script, we can take just a regular JSON object, just a regular raw JSON object. This is not an object in some special format. It's just some JSON that we're going to wrap in this model.get. And this is using ECMAScript Harmony proxies. And ECMAScript Harmony is the next version of the JavaScript language. And we're really excited about proxies because they give us a way to take any JavaScript object and then look at all of the operations that you might do on it. So when you change it directly, add some property, delete something, add something to an array, change some value, we can get informed of that. We can listen in on that directly so that you don't have to send your data down the wire in a special format in order to have it wrapped up in something that can then notify you back about changes to it. We can just wrap it directly. We will also want to add a new model property to all HTML elements. In this case, the model property is something that's inherited. So if there isn't something else in the document that's going to iterate or use a template, we'll see the items that were inherited from wherever this element was used in the document, which means that the items property here in my JSON is going to be the thing that we iterate over. We're going to go run through all the items, and if they've got children, we're going to apply this template once again, while pulling the name property right back out of it. So this is pretty cool. This is in 20 or so lines. We've got the real ability not just to go generate UI on the client side, sending down significantly more terse data, but also wiring up the behavior of observing data change and modifying the UI. Let's look at an example of how this might work. We've built, again, a prototyping library that helps you work with this stuff today, and it works in Mozilla Firefox because they've got great proxy support. So I'm going to pull up Firefox. And what I've got here is an example of a recursive template. This, again, is available as a Google Code project, google.code.com/p/mdv. And model-driven views give us the ability, if I look at the source code for this page, so we have our template, and we've got our data, and it's exactly what we saw before, and this is all driven by this little library. I commented a bunch of stuff out. But let's see what it looks like live, right? So this page, loaded pretty fast because it doesn't have to send down an exploded version of all the HTML. But that model is also live. That model is something I can change. So let's go and do that. I'm going to come back in here and grab a snippet of code, which if we can read this. This code just takes the model. It's got some items. We're going to read it back out. And we're going to add a new JavaScript object to the front of it. We're just going to add a single object with a name property called Antarctica to the front of our items. We're just going to mutate this in line through Firebug. Great. Let's go paste that in. And what we see here is that the document got updated in real time. We didn't have to do anything special. We didn't have to say, please go re-render your view. Please go change everything about your document. In fact, it's only going to try to mutate as much of the document as the underlying data that changed. The model-driven views concept is incredibly powerful because it means that if you're going to script this stuff, if you're going to put an event handler on it, if you're going to hold references to some of this generated content, it isn't going to blow up from underneath you unless your data changes. This is an incredibly powerful thing. You're not going to have to be hands-off on the DOM that's generated from these templates. And we think this is a really critical feature, both for performance, because we're only calculating and updating as much of the UI as has changed from the data, but also for scriptability. We want to maintain the contract that you implicitly have between your data and your view. If you change your data, your view should update, but only the parts that would have otherwise been updated. So model-driven views are the sort of thing that are incredibly powerful. We hope that other web engine vendors will help us out and help inform us about what's working well and what's not in this system as we go to take it through the standards process and put it in implementations. But the question for you is sort of between JavaScript, between CSS, all the CSS improvements and the model-driven view stuff, when can you start to use it? It's an important question, and we've been using a series of prototypes to help us start to write real code in these systems. Our view has been that if you propose a new spec and you don't have an implementation, you don't have a way to run real code through it, you're going to sort of miss stuff. We have a long history of sort of missing stuff in the web platform. So if we can use prototypes to write a lot of real code in these styles today, we can catch a lot of the stuff early. And in fact, we've been working with some of the authors of some of the existing systems like Less to help inform our view of what the platform can do and where the gnarly corner bits are that we're going to have to watch out for early. And so we hope that you'll join us at these open source projects. Start using this stuff, start using these prototypes, and start working with it in your own code insofar as you can to give us feedback. Help us understand whether or not these new features are right for your application, whether or not they're solving the pain points that you're seeing in your apps, because we took a survey of our apps, but we certainly aren't the entire world. And we're really curious to know if this is the sort of stuff that's really going to pay off for you. The next step in the standardization process is always to get browser vendors to implement things. It's one thing to say, we think this is going to work in a JavaScript library, we think this is going to work in a prototype, but we really need to know whether or not it's going to fly in a performant way in an implementation. And so Mozilla Firefox, Chrome, we're all starting to work early in standards, as we've done with things like the file system and with the video tag, to go add new features to the web platform quickly so that you can start to use them in places like the web store or in extensions, things that aren't subject to the churn and the regular set of constraints of deploying an application to the full web. And things like Chrome Frame, the sorts of protected environments that are adding new features quickly and auto-updating are going to help make the future of the web platform a reality, but we need your help to do it. We need you to help work with us to try out these features. Give us feedback. Help us understand where you're still spending a lot of time writing stuff out for the savant and not saying what you mean. Because we really need to get to a place, we think, where when you write a web application, when you go and construct something, you're spending time thinking about what it is you're trying to get done and less time thinking about what it is you needed to say to get it done. So thanks so much. I think we'll open it up for questions now.
So we've got some mics here in the middle of the room. If any of you want to come up and ask questions, we would be happy to take them. Looks like there's one in the back. Yes?
Hello. Thank you for the talk. I was wondering if you're familiar with the App Engine Channel API, and if so, how that technology relates or compares to the WebSockets technology.
So if I recall, the App Engine channel, I think, is that Browser channel?
Browser channel.
All right. So Browser channel, what it essentially does is it opens two concurrent connections. One is for downstream, one is for upstream. And so first of all, one difference right there is you've got now 2 connections to your backend instead of 1. And if you're scaling up to a large number of users, the number of connections can actually become a limiting factor. So that's one difference. 2, even though you've got that, you're still oftentimes having to close. I forget if it's the upstream or the downstream connection. I want to say it's the downstream connection you have to close each time you send something. Otherwise, there are intermediaries that will cache whatever is being sent, or buffer it essentially. So you end up closing it, creating a new connection. You then have all the cookies that get sent, all the headers, and so your data transfer gets blown up by a lot. So WebSockets has 1 connection instead of 2. It's persistent, so you don't have all the headers going each time. And WebSockets also supports binary data. So if you're sending binary data, you don't have to you don't have to base64 encode it. You don't have to like shove it in some giant string or giant JSON format. You can just send like whatever binary data you want. So WebSockets is really designed to be a more efficient implementation of bidirectional communication. So same use cases, but much more efficient.
And I should say, too, that the channel API today sort of presents a simpler case to you, the user of the API, but it is ultimately doing this stuff under the covers, which has all the extra headers and the closed connections and all this extra stuff. WebSockets doesn't.
Thank you.
This is probably a little early to ask, but I'm curious with the model-driven views. If you go and inspect the DOM and try to edit it later, are you editing the template? Are you editing the rendered result? Or do you get to choose which side you're on?
So when you go with model-driven views, right, our goal here is to sort of extract out the latent data model that's already in HTML. Like if you think about structuring your HTML, you've got form inputs, you've got the hierarchy of your document, you've got semi-semantic tags. In that case, we just sort of want to make it easier for you to transition to a world where you're modifying your data and not so much modifying the DOM, right? If you can get away with modifying your data and propagating sort of like input events, say, back to your data, to your model, and then have that regenerate the DOM that you've got, that's the nirvana, right? That's the place where we all want to be, where we don't have to go think so hard about what's going to happen when I modify this piece of DOM. If you do have to go modify DOM, the template isn't live. Unlike Zool templates, or sorry, XBL2 templates, you wind up in a place where if I change the template, which you can do later, it will take effect the next time I apply it, the next time I stamp out some new instance of that template. But existing instances of the template aren't affected. If I go and change the generated DOM, there's the potential that we may sort of disconnect the two. We don't want to really sort of keep you from doing that, but you may no longer see updates that are generated back from the model.
In the back, I think. Let's just alternate.
Yeah, I just had a question. I built a small HTML5 thing for myself that used the HTML5 audio tag, and then I was dragging and dropping files from the local computer to then populate that audio tag. And I ran into a couple problems with actually dropping a blob onto the page and totally crashing the page by dumping 5 megabytes of memory onto it. But I'm wondering how the Filesystem API and the HTML5 audio tag or the HTML5 video tag could interact with each other, and if that's being thought of.
So without knowing the exact details of your implementation, like there are certainly ways that you can like try to get a data URI from whatever is dropped on, and then that turns into like some giant amount of memory. One of the cool things that comes along with Filesystem is a class called FileReader. So you can essentially, rather than having to get just like the whole contents of the file and put that in some data URI, you can use FileReader to seek around parts of the file. You can get a URI that you can then put inside the source attribute of an audio or video tag. So what we're really trying to do is we're trying to make sure that anything you store in the HTML5 Filesystem API or anything that you get a reference to, like if someone drags a file on or someone chooses a file from an input type equals file dialog, We want you to be able to get sort of a handle to that file and then do intelligent things with the file wherever it already is without having to copy it. So get a URI that you can shove in an image tag, a video tag, an audio tag, open a file reader or writer that you can seek and read or write parts of the file. Like, we really want, like, all these things that you can do on Unix when you just fopen a file and you can fseek, fread, fwrite. We want to enable those same types of use cases in a way, obviously, that's safe for the web, but in a way that's equally performant and expressive. So that's really our goal.
That's great. That's great. Thank you very much.
Cool.
Hi. I would like to ask, what is the plan for the hardware or device support in HTML5? Starting from, for example, most common devices like the webcam or the microphone, on going further, for example, with the smart card readers, fingerprint readers.
We have a team of people that's working on microphone and camera input. It's not quite there yet, but we do want to make it so that you can do, like, we have a whole group inside of our team that's focused on what we call real-time. So how do I get access to the microphone and video camera? That's one part of it. But then once I get access to it, what do I actually do with it? Like, it's one thing to be able to just like put that into a canvas or video tag and display it on the screen. But then how do I take that data and transmit it somewhere? Like, if I'm doing streaming, I don't really want to use WebSockets because that's TCP. And if I'm on a slow connection, I'd rather just drop frames than, you know, make the other guy wait. So we're not there yet, but we are doing a lot of work around video and audio and streaming that in particular. As for other types of devices, it's sort of an open question. There's a few proposals for how to deal with sort of letting the browser interact with types of devices it doesn't know about yet. So like a new input device, a new gamepad. It's still sort of in the early days of specs. There's not really that much that you can play with at this point.
My personal hope is that we get to a place where a lot of these things have an easy on-ramp and then a sophisticated API behind them. So the easy on-ramp traditionally in HTML has been the input tag, right? So if I have the device capability, the input tag gives you access to that thing, files, for instance. That seems like a good analogy that we can continue to carry forward, where you can hang a sophisticated DOM API off of it later, but still have an easy on-ramp for web authors. So there's a lot of permissioning questions, a lot of like, how many info bars are we going to throw? It's complicated, but it's coming.
Thanks.
Hello. With the new templating scheme that you showed us and all of your data living in JSON somewhere, what would be the implications for SEO?
So that's a great question, and in fact, my hope is that because a lot of this can be declarative, what we showed you was the data in JSON, but the template in HTML. Those things don't have to be that way. The data could be HTML, right? So if the data is HTML, then you've got the content that you're trying to express there. And if that has the links and the content that is important to the web engine, it gives you degradability for one, but it also gives you the ability to have it search for the other. The other question, the important question is, how smart can the web crawlers be? How much of this can they redo? So if a lot of that is declarative, again, we showed you sort of the imperative version, but if a lot of it's declarative, then there's hope that we can not have a big gap in support as this stuff rolls out.
And hopefully it actually makes it easier. Like, if you look at a lot of what obviously there's Google.com, but there's also inside of Google.com, there's things like product search and trying to extract meaningful actual like data, not just strings of text, entity recognition. Hopefully this would actually make that easier, but we are still in the early days.
Okay, thank you.
Hi, Alex. The data binding, the model building, what's different from the Sprout Cloud framework today?
It's built into the platform. You don't have to send it down the wire. So a lot of these things, I should say, are predicated on not inventing something brand new, but looking at existing best practice and trying to work backwards and say, what could we do in the platform if we had the power to change the platform? Because a lot of toolkits, like the ones I worked on before I joined Google, can do a lot of the same things, but they can't do it in as natural a way. So the opportunity for the platform is to do it express the capacity in the most natural way for you as a developer. And so not to go necessarily plow new ground entirely, but to go figure out what's working and then just make it faster, easier, and simpler for web developers.
Okay, thank you.
a template that was basically a for loop. Oftentimes in templates, like in Django, we have like if, but I know, which is useful, but I know also some people are uncomfortable with things like if in templates. So how far are you guys going to go in terms of that stuff and logic?
So there is a small expression language, basically, which ties back to JavaScript, but that's, again, not going to be language dependent. It won't tie necessarily to JavaScript, whatever's there. But the hope is that you won't have to rely on that. If a property isn't available, there's going to be a pipe filter syntax, like you might see out of, there is a pipe filter syntax in the MDV prototype today, the sort of thing that you might see in Django, where you can run filters through. And so one of the things you can do is specify the hidden property from HTML5. So if you want something to not be output, well, you can just hide it. And that gives you the ability to do a lot of conditional logic based on the structure of your data without necessarily going to programmatic expression, which again is going to be the sort of thing that defeats SEO or machine recognition of what you've done.
Hey, what's the status of IndexDB, and how long do you think it's going to be practical before we can actually make end users have good use of it?
Yeah, so right now we've got support for all of the asynchronous IndexDB API. We have support for all of the asynchronous IndexDB APIs on Chrome Dev. We're doing a few things right now to make it more performant. So our initial implementation was using SQLite as a backend, and we found this to be sort of unacceptably slow for a lot of transactions. So we have a new backend called LevelDB. We're working on trying to get that in Chrome 13, as well as working on a synchronous set of APIs for IndexDB that are available from workers. So hopefully in like by the end of the month, it should be pretty usable with the new backend. There's a chance that might slip into early June. But definitely very soon, we will have the new backend and all the IndexDB asynchronous and worker synchronous APIs working in Chrome. So broadly, summertime.
Thanks.
Hi. Are you working on standardization of background pages or background apps?
As we both look at each other. So, we had this interesting discussion over beer a night or two ago about background pages versus workers. And workers are absolutely awesome because there's a lot of things that you want to do off the main thread, some heavy computation, but then there's also things you want to do off the main thread that require some access to the DOM. And so the prototypical example of this is image manipulation. Sure, you can try to code everything up in JavaScript, but it'd be really nice just to have a canvas in off the main thread that you can do manipulations with, but you can't have a canvas without the DOM, so then we get into this whole thing of background pages. And yeah, I mean, there's a lot of great use cases for it. There's also things like, I've got an offline email app and it wants to check for email every half hour, and how am I supposed to do that? It's something we're trying to figure out. We don't have a clear path right now, but there's so many use cases for it, we have to figure out a way. It's just a matter of when and how.
This is the return of mutable shared state, right? That's the thing we never want to get into as a platform. We never want to have some other thing running in parallel to your application, which can go unexpectedly change that stuff out from under you, causing you to have to create some mutex primitive or something like that. But at the same time, we need sort of zero copy or one copy access to a lot of those things that we can shuttle them back and forth across these processes. It's not clear exactly how this is going to be won, right? Maybe there's some model like transactional shared memory, something like that. But for now, we're doing this sort of one-off. When you have a big use case, like image processing, let's make canvas data available. So those are the sorts of things where if we can see where computation is going to be needed and we can offload it, maybe we can build a bridge from the DOM to that computational unit.
The reason I'm asking is it's one of the last things missing to have an alternative to native Android apps with HTML5, because you don't have those backgrounds wake up the app or something with HTML5 apps.
Yeah, I think it's part of a much broader question, which is sort of how do we get away from the model where the application always has to be running? On Android, I don't have the entire mail application running all the time, and yet my email is still syncing. How do we get web applications to a point where they can be told by a server that something interesting has happened and they should process it without having to run the full application? I think that's sort of a broader question that we definitely need to solve, especially as we try to target mobile devices like phones and Chromebooks. And I mean, it's something we have to solve.
So the question is, like, which part of the web platform is going to reach down and intercede on your behalf with the OS? Open question.
Yeah. All right, well, thank you all so much for coming. Really appreciate it, and I hope you have a great rest of the day here at Google I/O. Thanks again.